there's the general problem is producing energy or producing electricity, which is sort of like the most general purpose form of energy, in a way that does not fundamentally change the chemical constituency of the atmosphere or oceans. So sort of a sustainable energy production. As soon as you have sustainable energy production, and if that's combined with stationary storage and electric transport, that can cover all forms of all energy needs. Because I mean, roughly in a sort of very top-level view, about a third of all energy is electricity, about a third is used for heating, and about a third is used for transport. But there's enough energy coming to us from the sun to actually support all three areas. There's really an amazing amount of energy that comes from the sun. It's 1 gigawatt per square kilometer, which is mind-blowingly huge. And actually, if you think about it, the Earth is almost entirely solar-powered already, in the sense that we would be a frozen ice ball at a few degrees above absolute zero, if not for the sun. The sun powers our entire system of precipitation and almost the entire ecosystem. And then there's the energy needed to power civilization, which to us seems big, but actually to the sun it's very tiny. As I said, a gigawatt per square kilometer is a supergiant amount of energy, and at 20% efficient solar panels, that's 200 megawatts per square kilometer. I mean, what's interesting is if you look at the sort of clearance area of most nuclear power stations, you can generate more energy from solar panels than you can from that nuclear power station, which is quite amazing. All you need is 5 square kilometers to get to a gigawatt of power, which is a tiny area. Usually the clear area is much greater than that. So no problem to generate all the energy we need for electricity, for heating, for transport from solar, with some contribution from wind and geothermal and tidal. No problem at all. We just have to do it. And then we need to stop effectively subsidizing burning fossil fuels.